everyone, and welcome to lesson 24.2. We're going to skip 24.1 and jump right into 24.2, which starts on page 326, identifying those law of cosines. Now, officially, we can write the law of cosines three different ways depending on what angle/side you are talking about. So for instance, the first way we would write it is if we are given sides A and B and we're looking for little c and we're given angle c. So the way we would write this is, since little c is what we're looking for, we would write c squared by itself, and then the two angles that we are given, a and b, would be what we use inside here, a squared plus b squared, and then minus 2 times our given sides a and b, and then times the cosine of that given angle c. Okay. So notice each time we write this, it's all going to be dependent upon which sides we're given. Because if we're given then B and C and we're looking for A, if we're given B and C, A is what we're looking for, and we're given big angle A, it would be A squared by itself, and then B squared plus C squared minus 2 times B times C, and then we would multiply by the cosine of the given angle A. Okay, and then last but not least, when we flip it around one last time, this last time, if we are given A and C, and we are looking for B, and we're given big angle B, the side B squared is going to be by itself, and then we have A squared plus C squared, and then minus 2 times those given sides of A and C, all being multiplied then by the cosine of our given angle B. Okay, so basically what has to happen each time. Okay, we are going to use the law of cosines when we are given two things. And this is actually the last question on number 3. What kind of has to be the criteria to use this? You either need all three sides given, and you're going to be looking for one of the three angles, or you need two sides and the included angle, so the angle in between them. So that's why sometimes instead of memorizing all three of these, it's more important to memorize that you're setting this up, that the angle that you're given or the angle that you're looking for, side across from it on the other side of the equal sign, and then using the other two sides that you are given. Okay. So again, some people like to write down all three of these as their formula. Sometimes you just kind of have to write down just the first one, and then again understand that relationship that on the other side over here is the opposite of the included angle. Again, included means the angle in between the two. Okay. So now how do we use law of cosines? Well, law of cosines is useful to us when we have oblique triangles. And oblique triangles are defined as non-right triangles. So when we use SOHCAHTOA, we only use those with right triangles. Law of cosines, and eventually when we talk about law of sines, are going to be useful to us because they can be used for non-right triangles as well. Okay. So in number 4 on page 327 in your book, we see this diagram of the Ghirardelli Square in San Francisco, and we have this retaining wall here, and then we have these distances, and we want to figure out the length of the retaining wall. So law of cosines, okay, we have the angle in between two sides, and we're looking for this side across from it, right? So you could think of this as big angle A and little angle A, and side A, so little a, and then we have B and C. So we would have A squared, which again is what we're looking for, equals B squared plus C squared minus 2 times A times B times the cosine, and you're going to want to make sure you're in degrees here, of our angle, which is 105. Okay. So again, double check that you are in degrees mode before you start with this. And then again, you're going to just type all of this in. We have A squared plus B squared, and then minus 2 times A times B, and then cosine of C. And from there, we are going to want to square root our answer. And oops, I did double cosine. Wait a second, something doesn't look right here, so sorry. Cosine, just one time, of 105. There we go. This looks better. There we go. So ignore that first one. You get here, and then you will want to square root the answer to get just A by itself, right? Which is about 60.198 yards. So again, be careful when you type that in initially, that'll be A squared. So you will have to square root that value to get your final answer for just A, which again came out to be about 60.198 yards. Okay, now we can also use this then to help us figure out the distance in number 5 from the distance between the Golden Gate Bridge and Alcatraz Island, right? So that's near Ghirardelli Square. So if you were escaping from Alcatraz and swimming to the Golden Gate Bridge, how far of a swim you are going to need to do. So try that one on your own. Right, you should have got that x squared equals 3.2 squared plus 1.4 squared minus 2 times 3.2 times 1.4 all times the cosine of 80. So you're going to end up square rooting that answer that you get inside there. You should have gotten 3.263 miles. I don't know about you, not worth shark-infested waters to try and swim that for me. Hopefully don't have to go to Alcatraz, though. Now, the next piece that we would use the law of cosines for is being able to find the angle. So again, if we have the annual Escape from Alcatraz triathlon, we have this 1.5 mile open swim from the island to Aquatic Park. So from our island to the aquatic park, we have a 1.5 mile swim. And then due to the strong currents, swimmers aim for a tower located 0.3 miles upshore from Aquatic Park and 1.25 miles from Alcatraz Island. So if we label this diagram that they have on page 327, we have our 3 sides. And we want to figure out what is the angle between the course the swimmers set out and the actual course they swim the race. So this little angle in here. So this is our degrees that we're looking for, right? X degrees. So we can solve for this island. So what we're going to notice is we're looking for this angle. We're given 0.3 across from it. So 0.3 is on the opposite side. And then our 2 sides around our angle are 1.5 squared and then 1.25 squared. And then minus still 2 times 1.5, 1.25, and then cosine of that angle we're looking for, okay? Now, the typing into the calculator is going to be a little bit different on this one because we have to be careful. Because notice we can't type all this in together because the cosine of x is being multiplied by here. So we're going to have to start by actually isolating this negative 2 times 1.5 times 1.25 times cosine x. So to do that, we're going to need to subtract from the left-hand side the minus 1.5 squared and the 1.25 squared. So that's going to go away. And we're left with 0.3 squared minus 1.5 squared minus 1.25. And you get this negative answer, and that's okay right now. So we have negative 3.7225, and then that's equaling negative 2 times 1.5 times 1.25 times cosine x, right? So gotta be careful here. Now we're going to simplify this piece, right? We're going to simplify this, and we're going to divide that over, right? So if we have negative 2 times 1.5 times 1.25, we're now going to divide this piece over. So this was negative 3.75. cosine x equals our left-hand side. We're going to now divide this over to get the cosine of x by itself. Negative 3.7225 divided by 3.75. This now is what we are going to have to take the inverse of cosine-wise, okay? Because right now we have this 0.9926-ish equals cosine x, and to get the x, we need to take cosine inverse of that decimal to get our final answer. Now, I recommend second cosine, just typing it in. Instead of having to type all that in, do second answer, so it just saves that answer in. And we have about a 6.943 degree angle. So a very tiny angle, but probably a lot when you're swimming would be that angle. Now, from there, we have a couple more examples talking about some isosceles triangles. So they have the isosceles triangle with lakes 8.5 and 10.5. So imagine if we choose in our isosceles triangle the two sides to be 10.5 as opposed to then the base being the 8.5. We want to solve then for these missing sides, angles in our triangle. So if we look for, let's say this angle down here, again, the side across, we have the 10.5 degree angle by itself, and then we're going to use the other two angles, minus 2, and then again, cosine of x, always cosine for the law of cosines, right? So again, we got to start by subtracting these over. 10.5 squared minus, we're going to subtract over from both sides, or from the right side, the 10.5 squared and the 8.5 squared. And then we're still left with this negative 2 times 10.5 times 8. Now, if you don't simplify this first, if you're trying to be lazy in your calculator, if you divide your answer by that, make sure you divide it by parentheses negative 2 times 10.5 times 8.5. Again, don't forget the negative and the parentheses. And you should get this. And then this will be what we take cosine inverse of to get our final answer of 66.12 degrees. Okay. Now, if this is a 66.12 degree angle, so is this other angle, because they are equivalent, right? If these are congruent, these are congruent. And then we can find our last angle by just subtracting from 180 degrees, since that's how many total degrees are in a triangle. You would have 47.76 as your remaining angle. So 66.12, 66.12, and then 47.76 degrees. These would be our three angles. Okay. Try on your own if we set this up so that now the 8.5 degree side is the congruent, 10.5 is by itself, and again, start solving so that you can find your three remaining angles. Now you should have got on that, that these came out to be 51.86 degrees this time. So this is also 51.86, and then to subtract from 180, our last angle will be 76.28 degrees. Okay. Now, side note, back to geometry land. If they told us about a different isosceles triangle, there's only actually one possible way to write this. And the reason that you would have to write it as 12, if you tried to do these as 5.8 and 5.8, 5.8 plus 5.8 is not bigger than 12.2. And back from your geometry days, we know that the two smaller sides have to add up to be bigger than the third side, otherwise a triangle won't be formed. So that's not possible. The only way you could actually draw this triangle is that these would be the isosceles sides, and then 5.8 would be the base with the legs being that. Because otherwise it would not fit the triangle inequality theorem. Just as a side note. Okay. All right, our last problem of today is dealing with a word problem, and the first part here, and this is on page 328, you're going to want to draw a picture. Okay, so notice we have two ships leave the dock at the same time. So here's ship one, here's ship two, here are my ships. You know, I'm very artistic. You see our ships, right? And it says that they travel in two straight lines so that the angle between them is 52.1 degrees. Okay. And the one ship travels at a rate of 15.8 miles per hour. The other travels at 12.16 miles per hour. Now, the problem with this information is that they're giving us miles per hour. They're not giving us a distance, right? And the reason that this is a problem is because what they're asking for is how far apart they are after 4 hours. So we need a distance. If we're looking for distance, how far, we need a distance. So first thing we're going to do is we're actually going to convert these, because after 4 hours of traveling at 12.16 miles per hour, we've actually traveled 48.64 miles. And then after 4 hours traveling at 15.8, this one would have traveled 63.2 miles. Okay, so now that we have that information, we can set up to solve. I'm going to solve it up here. We can set up to solve for x squared because we have the two sides, 63.2 squared, 48.64 squared, and then minus 2 times 63.2 and 48.64. Cosine of 52.1 degrees. So take a moment to calculate that. Should have gotten x to be about 50.83 miles. Okay. Now, if they start changing course after 4 hours and start moving towards each other, how long will it take to meet that? Well, this actually turns into an algebra 1 equation because they're traveling for the same amount of time. So one's traveling at 12.16, the other is traveling at 15.8, and we're trying to figure out how long is it going to take them now to travel that 50.83. Well, 12.16 plus 15.8, that's 27.96. And when we divide by the 27.96, it's going to take about 1.82 hours for them to meet up. Okay. We will definitely be working more with the law of cosines in class. Thanks everyone for watching, and see you